In this video we're going to look at vector calculus. If a body moves through vector space, we can apply the same technique as before to cases involving variable acceleration. Each component of the vector is a function of time and must be integrated or differentiated separately. So if we've got s equals xi plus yj, then the x is going to be some function of t, and the y is going to be some function of t as well. Then the velocity is going to be x dot, so that's our dx by dt and dy by dt, and x double dot would be d2x by dt squared and d2y by dt squared. So whatever the components are for x and y, we're going to differentiate them, and that would be going from s to v to t, or s to v to a. Whereas if we're going back the way, we then have to integrate. So in this example, we've got a particle that moves such that at time t seconds, its velocity v is given by v equals 3t and t squared minus 4j. Remember, another way we could have that is 3ti plus t squared minus 4j. Find the speed of the particle when t equals 3. So that's speed, not velocity, but we need to work out the velocity first of all. So when t equals 3, v is going to be 3 times 3 over 3 squared minus 4. So v is going to be 9, 5. The speed then is the magnitude, so it's going to be the square root of 9 squared plus 5 squared, which is square root 106, or 10.3 meters per second to 3 significant figures. Part B, find the values of t for which the particle is travelling parallel to I. So if it's travelling parallel to I, then the j component is 0. So we want j to equal 0. So that's going to occur whenever t squared minus 4 is 0. So t squared is going to equal 4. So t is going to be the square root of 4, so plus or minus 2. But of course we can't have a negative time, so then we get t must be 2. Part C, find the acceleration when t equals 5. Now acceleration is the rate of change of velocity, so it's going to be dv by dt, which is the differential of 3t and t squared minus 4. So that's going to be 3 and 2t. When t equals 5, a is going to equal 3 and 10, or 3i plus 10j meters per squared second. Part D, the displacement of the particle at t equals 4 seconds, given that it's initially at the origin. So initially that's whenever t equals 0, and it's at the origin, so s is going to equal 0 as well. S is the integral of v dt. So we're going to integrate 3t, and we'll get 3t squared over 2, and integrating t squared minus 4, we'll get a third t cubed minus 4t, but we'll also get some constant c. But we know at time t equals 0, s equals 0, so that means that c must also equal 0. Then we're wanting to find whenever t equals 4. So when t equals 4, then s is going to equal 3 over 2 times 4 squared, which is 24i, and then a third times 4 cubed minus 4 times 4, plus 5 and a third j, and that's meters. The next example then, a particle p moves such that at t time seconds, its displacement s is given by t cubed minus 4, and that's in the I direction, and t squared minus t in the j. Find the speed of p when t equals 2. So speed, we're thinking about velocity, and to get velocity, that's ds by dt. which is going to be 3t squared and 2t minus 1. When t equals 2, the velocity is going to be 3 times 2 squared, so that's 12 in the I direction, and 2 times 2 minus 1, 3 in the j direction. So that's the velocity. Then to work out the speed, it's the magnitude of the velocity, so it's going to be the square root of 12 squared plus 3 squared, which is the square root of 153, which is 12.4 meters per second. Part B, find the value of t for which the y coordinate of s is a minimum and the displacement of p at this time. So we want the y coordinate or the j component to be a minimum, so we're going to have to differentiate that, and it's the s is a minimum, so we're going to differentiate the s equation. Now we've already done that to get 2t minus 1, and then for max or min we want d by dx to equal 0, so that means 2t minus 1 is 0, 2t equals 1, t is going to equal a half. For the nature we need to check the second derivative, and d2s by dt squared in the j component is going to equal 2, which is bigger than 0, therefore it's a minimum, which is what we wanted. So whenever t equals a half, we're going to have a minimum value for the y coordinate and the displacement at this point. So when t equals a half, s is going to equal a half cubed minus 4, which is minus 3 7/8 in the I component, and in the j direction, minus a quarter, and that's meters. Example C then, find the average velocity of p from t equals 1 to t equals 3. So average velocity is going to equal the total displacement over the total time. So what we need to know is the displacement travelled from t equals 1 to t equals 3. Now we don't need to worry in this example about turning points, because we know in the previous example, the previous part, that t equals a half would be a minimum value, and it was the only minimum value for the y coordinate. If we think about the x coordinate of t cubed minus 3 and any turning points it would have, so if we differentiated, it would be 3t squared, and that's going to be equal 0, and then t squared is 0, so t is 0. So there's only turning points when t equals 0 for the top, and for the j or the y coordinate it's when t equals a half. And because we're looking from t equals 1 to 3, we don't need to worry about that. So all we need to do is find where the particle is at t equals 1. So when t equals 1, s is going to be 1 cubed minus 4, so that's minus 3, and 1 squared minus 1 is 0. When t equals 3, s is going to be 3 cubed minus 4, so that's 23, and 3 squared minus 3 is 6. So the total displacement is going to be the change in the displacement. So we'll do 23, 6 minus 3, 0. So that's 26, 6. So really we can see in the I component it's gone from minus 3 to 23, so a distance of 26. And in the j component it's gone from 0 to 6, so that's a change in 6, so it's 26, 6. So filling that into our average velocity formula, it's 26, 6 divided by the total time from 1 to 3 is 2 seconds. So then that's 13.3 meters per second. Next example then, if v equals t squared I plus 3tj, and initially s is 18i minus 24j, and remember that's whenever t equals 0. So to get a is the rate of change of velocity, so a is going to be dv by dt. which is going to be 2ti plus 3j. When t equals 2, a is going to be 4i plus 3j. Part B, s. So s is the integral of v with respect to t. So if we integrate t squared, we're going to get a third t cubed I. And then integrating 3t, we're going to get 3t squared over 2j, and then plus some constant c. Now what we have is when t equals 0, s equals 18i minus 24j, and then c also works out to be 18i minus 24j, because whenever we substitute t equals 0 in, we eliminate the I component, we eliminate the j component, we have the s equals c, so then c is 18i minus 24j. So we could write s as a third t cubed plus 18i plus 3t squared over 2 minus 24j. And that's just by collecting the I and the j components. Now when t equals 6, substituting that in, we get the displacement, and s works out to be 90i plus 30j meters. The next example then, find the force acting on a mass of 2 kilograms with position vector r equals t cubed I plus 2t squared j. So what we have then is that a position vector is really where it is, it's a displacement. So if we are going to work out a force, we'll be thinking about F equals ma, so we need to get to an acceleration. So to get from S to A, we've got to differentiate twice. So V is going to be the differential of R, so that's going to be 3t squared I plus 4tj, and then A, differentiate again, we're going to get 6ti plus 4j. So F equals ma, which is going to be 2 upon 6ti plus 4j, which is 12ti plus 8j. And that's a force, so the units are newtons. And our last example then, if the velocity of a body at time t is given by v equals 3t squared I minus 2tj, find expressions for the acceleration and the displacement at time t, given that whenever t equals 1, s equals 3i minus j. So v, 3t squared I minus 2tj. Acceleration is the rate of change of velocity. So we need to differentiate that, and we get 6ti minus 2j. When t equals 1, the acceleration is going to be 6i minus 2j meters per squared second. To work out the displacement then, the displacement is the integral of v with respect to t. So we'll be integrating 3t squared, which will be t cubed I, and then integrating minus 2t with respect to t, we get minus t squared j plus some constant c. Now we know that when t equals 1, s equals 3i minus j. So we're going to have to substitute that in. So 3i minus j is going to equal I minus j plus c. So c then equals 2i, and the j's cancel. So our expression for s then is t cubed plus 2i minus t squared j. And obviously we don't need to substitute in t equals 1 because we know the displacement. Meters.